This is questions under dimension analysis. This particular topic is very common in YT these days. In the last 3, 4 to 5 years, YT has been setting questions in the theory part when it comes to dimensional analysis. So that's why I feel like we should look at the next 2, 3 weeks. I'll be sharing a video of dimensional analysis on the YouTube for students to have enough knowledge of this particular topic. So let's look at this question. A body is moving through a resistance medium such as here it experiences the drag force D. So the force given to us here is denoted by D, which opposes the motion. The D is given by, that is, the drag force is given by 1/2E. This is a particular symbol, AV square. So each of the symbols that we have, the letters that we have here, they tell us the meaning of each of the numbers here. That is, if you have a particular equation in dimensional analysis, there will be a statement under it that will tell you what each of the letter represents. As this V here can still mean volume or probably velocity, but the statement under it tells you what each of the letter represents. As this symbol here means density of the resistance medium. A means area, that is effective cross-sectional area, while B is reversed as what is reversed as velocity. And C here is a drag coefficient. So we have to show that this C here has no dimension. That is, the value of C here, it has no unit. Or probably you can say you should show that an equation is homogeneous. That is, probably the left hand side is equal to the right hand side. Or probably you should find the value of C. So the value of C that will make this C to be dimensionless constants is what we have to find. That is to show that this C here has no unit. Now we have D is equals to 1/2C this AV squared. And we all know that this D here is the drag force. So this is reversed as force. And dimensional analysis, your force is mass times acceleration. So as if your mass is m, and is what is meter per second square. So we are replacing this D here by D. So we're going to have ml h raised power minus 2 because this D here is force. So here we now have 1/2. This C here we said is a drag coefficient. As far as C is concerned, it has no unit. So we are repeating that C again. Why this symbol is representing what? Density. Now if you remember, your density is what is mass over volume. Density is mass over volume. So mass will remain m, while volume is L cube. We're going to have ml raised power minus 3. So here we have ml raised power minus 3. So this A here is reversed as cross-sectional area. So your area will be reversed as length. That is L squared. We have L squared here. So whereby the volume, this one is velocity, and velocity is what is L3 raised power minus 1. Same thing as meter per second. So all raised power 2. So we're going to have L raised power minus T raised power minus 2 is equal to 1/2C L raised power minus 3 L raised power 2. So we are multiplying these two all through. We're going to have L square T raised power minus 2. So this will now give us ml T raised power minus 2 is equal to 1/2C. So all this one, what we have under it, all we have, the sign between them is multiplication. So we are breaking this together now. So we pick one out of this and we're going to add the power. So 5 is multiplication. So this is going to be L raised power minus 3 plus 4. That is 2 plus 2. And T raised power minus 2. So this will be ml T raised power minus 2 is equal to 1/2C. L raised power what? This one will give us 1 and T raised power minus 2. So now we compare. So you want to compare, you compare this side with this side. We're going to have m is equals to n. You compare m with n here. And this has cancelled each other. Likewise, we have L is equals to L. So this one too has cancelled each other. Next one is T raised power minus 2 is equals to 2 raised power minus 2. Likewise, it has cancelled each other. So we simplify that our C is equals to 1. And 1 is not meant to be unity. So that's why the value of C here is what is dimensionless constant. As a result of that, we have shown that as far as C is concerned, C has no unit.